My bid. All right, we're starting with number 5. Seems like the best place to start for some reason. I don't know why. All right, so we're talking about reasonableness. So when we say reasonableness, we're talking about x's and y values that we can use for the given situation. When we're talking about reasonable graphs, we're talking about maybe giving a picture for the given situation that can be applied, and that's it, nothing else, nothing extra. So number 5, so we're driving to Colorado for vacation. Once we get on the road, we're driving at constant speed. And the second sentence is the most important. It says your distance from Dallas depends on the amount of time you've been driving. So if I draw an x and a y axis, hopefully yours will look a little better than mine. It says your distance from Dallas depends on your time you've been driving. So what's our x-axis and what's our y-axis? By the way, it's number 5. All right, so distance here. And then what was our x's? Time? Alright, so when we pull out of the driveway or the parking lot or wherever we're leaving from, we kind of probably start off going kind of slowish or whatever. And then once I get to the freeway, what happens? I go faster, right? So what I'm saying there is that my speed increases, therefore my distance increases as far as speed goes. Like I'm traveling at a faster rate, so my distance is increasing at a faster rate as well. Now, if you look at the instructions above number 2, it's telling us that we got to write a graph, or draw a graph, write the parent function that deals with this graph, and then also give the domain and range. So what shape does this look like the best of? Yes, it's one. Parent function's linear. If you just had one diagonal line, that's fine too. I was just trying to be a little more realistic with speed and all that stuff. But once again, we're just talking about distance. Okay, once we got on the road, okay, that's fine. If you want to say that we just drove the whole speed the same speed, that's fine too. Either way, okay, and then the domain or range, can we start at 0? Can we start at negatives? No, we can't have negative time. So it can start at 0 hours. How long does it take to get to Colorado? 12, 14? Yeah, drive. 14 sounds good to me. And our distance, it's going to start at 0 again. And then how many miles away is our imaginary city in Colorado? 600? Any questions on where I got those numbers from? You don't have to draw that. That was just come with it or not. For that what? We just said that it probably takes 14 hours or so to get to Colorado from Dallas, estimated. And then said the biggest deal is that we're not going for infinity. We're not going for 100 hours, all that stuff. For range, estimate of 600 miles, I have no clue. If we drive 60 miles an hour, that would take 10 hours, but so I'm guessing we probably underestimated there, but it's all good. Any other good questions? Back with me. I am going to number 6. Alright, father pours himself a cup of coffee. He forgets to take it with him, silly goose. Leaves it on the kitchen counter. Go ahead and draw some axes there. Oh my gosh, I'm going to get it one day. Go straight up and down, Hank, baby. You can do it. Oh, perfect. Alright. Oh, goodness. Boom, done. Alright. So is my coffee, let's say we warmed it up, it's not iced coffee, okay? It's a warm coffee. Does it start off at 0 degrees? No, it starts off, I don't know what, 90, 89, I don't know how much coffee boils at or whatever gets warm at. So we're saying somewhere up here. It's going to cool down, right? So my temperature is going to drop down probably at a fairly constant rate. Is it going to drop down to 0? Is it going to cool all the way down to freezing? No, so it's probably going to level out at some point, right? All right, we have 2 parent functions here. 1 and 20. Yeah, linear. and constant. Thanks. All right, my reasonable domain and range. I probably start off at 0, right? That's when Dad leaves his coffee there. He's not going to leave it there forever. You're going to say like an average work day is 8 hours. So he comes home, grabs it in the minute, throw it in the sink, so 0 to 8. That's great. Our range. It's going to be realistic, we say room temperature. Room temperature is anywhere between 70, 76, somewhere around there.
72.
Great, 72 degrees. What do I want to say the hottest point of the coffee was?
100.
100. I don't think we need coffee boiling, but whatever. A little absolutely hot coffee. Sounds good. Questions, comments, concerns? This stuff easy? Does it make sense? Am I going too fast?
Yeah, it does.
Makes sense? Thanks, Parker. Numero ocho. In on that one.
Where is?
You are jogging, Parker, at a constant rate until you reach a hill. Uh-oh. Your speed decreases at a constant rate until you reach the top, and then increases constantly until you reach the bottom. Your speed is dependent on the position of the hill. So this time our y-axis is going to be and the x-axis, kind of weird, position on hill. Position on hill. All right, so we're jogging at a constant rate. So that's that, right? Because I got speed constant. All right, and then it says next sentence, my speed decreases. So does that mean up or down? That means down. So this is a constant rate, so it should be some sort of a line. We reach the top of the hill. Now what happens? We're running down now, so the speed increases.
Oh, you're running out. I thought you were like pausing.
We can pause if you want. If you want a little, right there. But that would mean we're still moving, so the speed would have to drop all the way down.
Yeah.
And then we'd be like, let's just do this. That seems a little more realistic, I guess. Okay. Then what happens?
To the bottom of the hill.
Then we're going to go, well, then we stop running? Or
Sure.
are we just going to keep running forever?
Take a break.
You just die. Just die. You want to say, like, our slowly decreases till we stop walking or running? Sure. Sounds great. All right. I see 3 or 2, maybe 3, depending on how you want to view this, parent function. Constant? Ooh, absolute value. Well done. If you want to say the middle little v there is 2 more lines, that's fine. You can argue that. That's really what it is anyway. All right, our domain. Now that's kind of weird. Position on the hill, like from 0 to the pebble. I don't know. But yeah, we can say altitude. We can say distance. We start at 0. You want to say like it's a 2-mile run or something?
Yeah.
Is that cool? Don't need to get real nitty-gritty here. Our range. So we are going to end at 0 miles an hour, so we can start there. And then Owen said 10. If you want to run a little slower, you could say 8 miles an hour or whatever. So for walks, you could say, I guess that would be quicker. Whatever. 0 to 8, 0 to 10, whatever your heart desires. If you want to critique your graph and say, well, I'm going to run faster up the hill, or sorry, down the hill, so I could go up like that or something. Whatever you want, but we all get the idea that we're trying to be reasonable here. So yeah, that's all I got.